On my workbench today, I have a Viking RC 311. This is a vacuum tube AM radio that was made between 1955 and 1963. Unfortunately, I don't have the cabinet. Somebody destroyed that, but I was able to salvage the chassis and the speaker, and the goal of this video is to get this vintage piece of equipment working. A few months ago, I was given this old AM radio that somebody had taken out of the cabinet. Now, I wish they hadn't scrapped the cabinet, but they wanted to turn the cabinet into a liquor cabinet. And they basically destroyed a beautiful wooden cabinet. But they gave me the radio and they gave me the speaker. And the lady that gave it to me said, "Don't plug it in, it smokes." Well, we're going to see why it smoked and see if we can get this old beast working. Nothing like an old vintage radio, right? Take a look at the back of this thing. First of all, we'll note that this is a Viking. So this would have been sold by the Eaton's company. See, it had a nice walnut cabinet. This probably was made in Canada too, I would think. Anyway, before I plug this thing in, we're going to start checking some common parts. We'll check capacitors and stuff to see if any of these caps are shorted. And then we'll see if we can make this thing put out any sound. So here's a look from the bottom. As you can see, looks like it's had a few of the caps have already been replaced. It looks like some of these look like they're a little newer than some of the old wax capacitors, the paper wax caps that are in here. Looks like a few of these may have been replaced at some point in time. But what we need to do is we need to check the filters, and we need to check a lot of these paper caps. So I'm going to check them with my meter for shorts first of all, see if I find any that are shorted. Keep in mind when you're working on any of these old units, you really need to do a good visual inspection to make sure that there's no shorts, and make sure none of the wires have been bent over and are touching together, especially one that you don't know the history of. And I don't know the history of this. It was given to me in this state just as a bare chassis. It had been sitting in somebody's garage for months before I got it. So before I do anything to this set, I'm going to give it a good visual inspection and see if I can spot anything out of the ordinary before I even consider applying power to it. Because the last thing I want to do is apply power to something that may have a short or may have a problem and create more problems. I don't want to risk burning up the power transformer or the output transformer, because those parts would have a very difficult time replacing if they were to become damaged. Now, definitely on a set like this, when I power it up, I'm going to put it through my 100 watt light bulb current limiter. That way, if there was a short, the light's going to light up bright and it's not going to blow any fuses. It's not going to do cause any further damage, because the light bulb will limit it to 1 amp. Well, none of the big ones are shorted. Now, a big rule when working on any vacuum tube equipment is that you have to be aware that there is several hundred volts to power the plate circuit in vacuum tube equipment. So these things are relatively dangerous to work on. You don't want to get your fingers in here and start poking around, especially because the capacitors can store a charge for a long period of time. If the tubes don't heat up to come into conduction, there will be nothing to draw that or drain that power away. So you can get a good jolt from these. So you really have to be on your toes and following all safety procedures when you're working on them. Now, I'm plugged into an isolation transformer. I'm also plugged into my current limiter, which will limit the consumption to 100 watts maximum. Because if I were to put a short on it, that light's going to light up. And that's the first thing I'm going to look at when I power this up is, does that light go real bright? Because that'll tell me if there's a short. We may have a short in the transformer, and if that's the case, well, this is a lost cause. But I see there's a few diodes in here too, so maybe I'll check them while I'm at it, because I see that there's a couple of diodes in here. So before I power this up, we'll just look and see if those may be shorted. These two diodes that I just spotted here that are soldered across the rectifier tube are actually from a prior repair, and a prior repair that was done incorrectly. And as you see here, one of these diodes is shorted. I'm getting conduction both directions. Almost looks like that is. It almost looks like someone's put diodes across the rectifier tube on this. Interesting. This uses a rectifier tube, but there's diodes across the bottom of it, like somebody has added their own full wave rectifier. Here's these wires come off the transformer here, right? And they normally go into the rectifier tube, and then the B plus is rectified off of the rectifier tube. Somebody has put silicone diodes. Take a look at this. If you look right down here, okay, this is the rectifier tube. Somebody has placed 2 diodes from the cathode to the plates. So maybe the rectifier tube is weak, and rather than replace the rectifier tube, they just put diodes in place of it and basically turned it into a solid state rectifier. I also noticed down here, further down on the board here, look at this botched job. Like, what the hell is this? Good work. Good God. Who's been working on this thing? Before I even consider putting power to this thing, I'm going to actually throw some more lights on in here so that I can get a better visual inspection, because just looking at this thing, we may have a short just with shoddy previous repair, plus the fact that there's spider webs all over it. But this is how I got the thing. I got the thing full of bugs. First thing I'm going to do is I'm going to remove this added on bridge that somebody's added, the diodes. I'm going to remove those because I just don't like the fact that someone's gone and tacked a couple of silicon diodes across the tube. And I can also measure them separately as well. Oh, that one's probably shot. 0.3. Oh, that diode's shot anyway. Well, there's probably our short right there. 0.5. Yeah, maybe these diodes are the reason why this thing, someone said it smoked. Let's just remove it. And then we'll try it and see if we get our B plus. Okay, we look at these diodes right now. This one's shorted. If we look at this one here, okay, 0.3 drop in this direction. If I reverse the probes, 0.5. This one here, open that way, 0.5 that way, you see? So this one's good, 0.5 drop, and it's open. This one here should be about a 0.5 drop here, but we're seeing a 0.39, but if I reverse the probes, we got leakage. So that diode, this diode here is shot. So let's just remove this one first of all. And that might be the problem. That might be why this thing's smoking, is that diode is shorted. I'm just curious as to why somebody put a diode in here in the first place. Again, the only thing I can think of is that the rectifier tube is getting weak. And rather than replace the rectifier tube, someone just stuck a couple diodes in there, which was not really a proper repair. But that's what some of the shops would do. Now that that is removed and this other diode is disconnected, it's just sitting here in free space, it won't hurt anything like that. I think now I can put some power to this thing and we'll see whether we get any B+. I don't think I'll have to worry about the thing going up in smoke now. I'm going to clip on my ground lead. I'll put my meter in AC mode, and we'll check to see whether we have any power coming off of the transformer here when I power it up. So I'm just going to turn on my power, get my fingers away from it, and we'll see whether we have any power. We have no power. Is our switch turned on? Oh, Might help if I actually plug the unit in. That would explain why there's no power. Power cord's unplugged. Okay, we'll check for power now. 155 volts AC. So that part's working, and that's part of the transformer. If we measure to DC, we'll see what happens when this rectifier tube warms up, whether we get any DC. As the tube warms up, we should see our B plus coming up, which we are. 70 volts. And that'll be here on this filter. So we're actually getting some voltage on this thing. It's not high enough. That's probably why someone replaced the this tube is probably weak. Now I am going through my light bulb, and it is lighting up a bit, so we are drawing some power. We're not drawing full power through it. But you see, I bet you if I hooked this thing up, I bet you if I hooked up the speaker to this thing, we would have some type of noise, because I'm just looking at what the hell this wire is doing out the back here. There's a wire here sticking out the back, and it's not the speaker. Guarantee you that it's not the speaker. Speaker terminal's here, and there's this wire that's just sticking out of the back, and it's one side's going to this tube here. Like, what the hell has somebody done? See this? I'm going to remove that. That doesn't look right. Make sure there's no voltage on it first, which is nothing. Yeah, somebody's soldered a wire onto one of the tubes here, it's probably one of the output tubes, and run it right to the back and out the back, and it's been cut off. What the heck is that for? I don't know, but it doesn't look right. And it looks like somebody's just added this after the fact. See what I mean? Those two wires are just cut off there. I don't know what that was put on there for, but that's not the output. This is the output transformer here, right? And as you can see, the transformer it's like someone put a speaker right across the output tube. That's real dangerous. That's going to have B plus, because the transformer here is fed off of B plus. Here's one line of the transformer here. This goes into the transformer, and the other ones go down to these are the push-pull outputs. You've got two tubes, right? There's one side of the winding, there's the other side of the winding there, and this is where your speaker output goes, is to this transformer. Here's your speaker terminals. I'm going to go grab the speaker, and we'll hook up the speaker. Let's see if I get any noise out of it. So here's the speaker that I got with it. The person that wrecked this thing just ripped the speaker right off of it and just threw it in the corner. But they did give me the speaker that goes with this thing, so it's going to be a properly matched speaker. Looks like there may have been another speaker here too that someone's taken out. If we look down here on the cabinet, right? It looks like there was two speakers in this thing, and someone's ripped one of the speakers out of it, unfortunately. And that might have been what that power was for. That might have been for a second. Actually, that might have been for a second output transformer. The red and black wires that I just took off may have gone to a second output transformer for another speaker. Or an electrostatic speaker. Some of the older ones had that. But this is going to be our speaker outputs here. Right, one lead to here. Looks like that's for a tweeter. It's got a capacitor on it, so it's got like you're going to have a ground here. This is going to be grounded. Right. What the heck? I think this test lead is broken. That would explain why my voltages didn't measure up to what they should have been. Let's get another one. That's a little better. So that's our ground for the speaker. Let's just turn that thing on again and see what the voltage goes up to now that I have a grounded lead that's not buggered up. Let's just see if our B plus comes up. It's a little more like it. It's getting up there. Still a little on the low side. But then again, I'm running it on low voltage because I'm going through a light bulb. So we got 100 volts B plus. I can see the dial lights are lighting up here. They aren't to the brightness they should be, so that's because our B plus is low. But again, and it's starting to drop here now. I bet you this tube is weak. But I want to see if I get any type of noise out of this thing at all through a speaker. So let me just grab something that represents a speaker and I'll hook it up. See if we get any sound through it. Okay, I have a speaker hooked up. Let's give this thing some power and just see whether we hear any noise whatsoever once this thing warms up. Voltage is 108. As the tubes start to warm up, the voltage will drop a bit. I expect it will. As the tubes go into conduction. Okay, now I have 300 volts on my my transformer here, which is more like it, 300 volts AC. I have nothing on the DC side. I think that this tube is shot. I see there's nothing there. Zip. Let's just see whether the tubes are lighting up. That's the tube that the diodes were on. So maybe that tube is just completely shot. Wouldn't surprise me. Oh yeah, it's shot all right. It's glowing blue inside. You probably can't see it on the camera here. If I kill some of these bright lights, this tube has gone gassy. It's got to come out. Let me kill some of these lights here. Okay, we're going to look down at this tube here when I apply power. This tube is lighting up blue. See? That tube is shot. Let's get it out of the circuit. Oh, I'll put a diode back in there and see whether I can get some B+. So this is a 5Y3. It's a rectifier tube. See, it was made in Canada. Oh, it's Marconi. This is a Canadian Marconi company. Shows how old this thing is. 5Y3. This one's gassy. Let's just put that diode back in and see whether we can get any B+. I'll only put one of the two diodes in. What the heck, eh? We'll see whether that will bring the voltage back.
So what I'm doing is I'm going to just connect one of the two diodes and basically put it in as a half-wave rectifier, which will be good enough for testing. That should get me enough voltage to the B+ circuits to bring the tubes into conduction and possibly get me some sound. So we'll try it with just one diode first.
But let's just see whether we get any voltage on this thing now. Any DC voltage. Oh yeah. Yeah, 200 volts. Yeah, that's a little more like it. That's a little more like it. And we're not drawing as much current through my little light bulb. It's not lighting up as bright. So let's just reconnect that speaker and see whether we get any noise on this thing. Don't hear a thing. Oh, wait a minute. I do hear something. Ah ha ha! I hear some noise. Oh, let's hook an antenna up to this thing and see if we can actually pick anything up. I would say that tells me that we got something going on. I got an antenna hooked up to it. If I touch the antenna, I don't want to touch the radio when I'm touching the antenna because I don't know whether the antenna is energized, right? Let's just see if we can get anything.
Afternoon, going to be a beautiful evening and sunset as well. Tonight clear to low 17 degrees. Tomorrow mix it out in the high of 25 by the water and 32 degrees in the valley. At the airport, 25 in the valley, 29.
Volume.
Vancouver, 27 degrees. We are the only Vancouver radio station with traffic and weather together. Alerts to get you there on time is on 30 times 413. 3 baby capybaras in a Toronto zoo now have names, which is music to many people's ears.
Needs an antenna, obviously.
And Neil, all names of the band members of classic Canadian rockers Rush.
A little bit longer wire, maybe.
Took weeks for zoo staff and animal experts to track the beaver like rodents down. Then finally last February, the 3 babies appeared, and nearly 45,000 people voted in a contest to pick their names. Coming up next in sports with Adam Forsyth. And we are going to hit the gridiron as the BC Lions are getting ready for their CFL season opener. We'll hear from Brian.
No, it's not much of an antenna, but...
It's a great time. FC Soccer on CSN Radio.
Tim Hortons presents Perfect Latte. Freshly ground premium latte. Balanced steamed milk. Only $2.99 plus tax. Just say latte.
It's got bass and treble. Bass and treble control for an AM radio. Incredible. The thing works. See, if I touch the antenna wire...
10% when you spend $100 or more during the Friends and Family event. Save $300.
Or at the gym, or at your wedding. Or wait, what? You're the best man. What do you think I was doing when you were dancing the polka?
Pretty cool. I don't know how old this thing is. I'm going to look this up and see how old this thing is, but this thing's got to go back to probably the 1960s anyway. It doesn't even have FM on it, so it could even be older than that. This thing could go back to the 50s. But there you go. There's an old vacuum tube radio working. I'll turn this thing over so you guys can see the tubes on it. Oh, that might explain why. That's not the antenna input that I'm hooked up to. This is it here.
Very good core. We know that to do this. We've always done athletes back there, and we're gonna have to play smart and do what we do. We're an excellent place. Different grocery store, a locally grown company that prides itself in providing locally grown produce and meat that's a cut above. Because at Fresh Street Market, you'll find only fresh beef, more selective than AAA. Certified beef is perfect for the grill. Exceptional marbling, unparalleled tenderness, and quality you can taste.
So there's the guts to it.
Discover where fresh meats every day. Fresh Street Market in West Van, Fleetwood, and Panorama.
We have our oscillator here. I think this is the oscillator. This will be the oscillator mixer, I think, or is this the... That could be the RF preamp, actually. Oscillator and mixer and your IF stages and the 2 output tubes here. All original. Looks like they're all original tubes. Well, these are Delco, these two. And what else have we got in this thing? These look to be Marconi's. 6BE6. Oh, we'll pull the tubes and just see what tubes this thing's got in it for the heck of it, eh? That way we know that it works. So we got a, this is a GE tube, so it's not made in Canada. This is a 6BA6. I believe this one's the oscillator and mixer. It's the oscillator for sure. This one over here in this can is, I don't want to break it. It's got one of these shields over it. This is more than likely the preamp.
The phono preamp is a 12AX7.
It's isolated from the rest of this. Oh, this one might be the phono preamp. This has got phono inputs on it too, so this might be. Just looking to see where it's connected here. That one just might be an amplifier for it because it does have a tape head and a phono input on the back. It's got two separate inputs. So this might be a preamp for that. I don't want to pull this cover off because it's kind of bonded. I don't want to risk damaging the tube. This would be the oscillator, probably the mixer tube, maybe just the oscillator. It's a 6BE6. This one might be the mixer over here. Good for the tubes. This one should be a 6BA6. Yep, 6BA6. IF stage. Another IF amp over here. Metal shield on it. This guy over here is a 12AT7. It's your dual triode. That's a preamp, audio amplifier to drive the output tubes, which are these two ones over here. They're both going to be the same. They are Delco. They are 6V6. I love it. License as stated on carton, made in USA, Delco. So those ones are 6V6. And of course the defective tube, the 6Y3, or the 5Y3. That's what the problem with this was, is this tube itself went gassy. And you know, who knows when this thing was serviced before, but whoever serviced this before found that that tube was bad, and rather than take the tube out of the circuit and just replace it with a diode or two, I only put one, well, I only wired one diode in. It's supposed to have two, so it's not getting the full voltage. I think I'll go see if I can find another diode, and we'll put another one in there and see whether it even brings up the sensitivity at all. But these capacitors here, looking at the date code on here, it says, well, patented. The patent was 1939, 1942, and renewed in 1945. So I'm going to guess that this radio probably was made sometime maybe in the 1950s. Maybe we'll look that up and see if I can find out when this thing was made. But very cool old radio, and it still works. So for someone wanting a collector chassis, hey, I have one. Not that there's much to listen to on AM radio anymore, but with the loss of our last AM music station to become yet another sports station, like, why do we need 3 24-hour sports stations in the Vancouver market, right? I mean, we've got 3 professional teams. We've got the Vancouver Canucks for hockey. They're going to be going to the new station because the company Rogers that has the rights to all the Canuck games, so they'll be going to the new station that just became a sports station from a oldies and middle of the road music station. And the other 2 stations are owned by the competitor Bell, and Bell has the rights to I believe they'll be carrying all the, well, it's TSN, right? So all the games out of Toronto. So that'll be the Blue Jays and the Argos and the Maple Leafs and that type of stuff. But anyway, I don't know. Bell owned both of the 2 other stations. So Rogers, or Robbers as we like to call them, they picked up the one remaining music station that played oldies, which was nice because that's what you listen to on an AM radio. You listen to the oldies so that it sounds nostalgia like it used to sound, right? So anyway, we've lost it. Now we've got it as FM stations, and all the FM stations play hip hop and crap, and they all sound the same. And you know, I wonder why nobody listens to the radio. I'm gonna see if I can find another diode, and we'll fix this thing right. It's probably overkill, but I have an MR856 here, which is a much higher rated diode than the one that I took out of there, which was a, what was this one here? A 1N4001. This is going to be much higher spec. This is 600 volts rated, so I think we're okay. Let's put this one in and just see if it improves our high voltage. It probably doesn't do anything, but let's try it anyway. So here we go. We had 330 volts before, but as the amplifiers warm up, that's going to drop a bit. Because we're only getting halfway rectification right now, so it dropped to 214. So we'll let the caps discharge. There we go. Now, of course, the proper way for the last repair shop that worked on this, the proper way for them to have done this, I mean, it's okay to replace the tube with diodes. That's not a problem. But what they should have done was he should have disconnected the input to it, taken the two wires to the transformer and just cut them off the lugs and put them right onto the diodes, and done the same for the anode side to remove it completely. You'd have to disconnect them all because the tube has gone gassy. You know, that's if you wanted to maintain the look, you know, so that the tube lights up. And if I were to sell this to somebody, a collector, for example, who wanted it to look original, I would put the rectifier tube back in and I would disconnect the 3 wires here from it. I'd leave the filament connected to it so that the tube would light up and glow red, like, you know, the orange, the filaments would light up, but I would disconnect the 2 wires going to the transformer and the wires going to the output transformer and to the B+ filter. That way it would be isolated from the actual tube itself. That way the tube could sit inside the radio and it would still light up like it's a functional tube, but it's not connected electrically to anything. That would be the way to do it. Or just to cut the pins off on the bottom of the tube here so that they're not making connection to the internal of the tube. That's if you want the thing to look original, right? And I mean, a collector who's going to collect a chassis like this wants it to look original. He doesn't want to have it with a tube that's missing. So, new diode in place. We'll check the voltage now and see if the voltage comes up any higher than it did before. And power. 300 volts. Let the thing warm up. Now we've got full wave rectification instead of just half wave. And I'm still plugged in through my current limiting device. Still going through the light bulb. But as you can see now, the voltage is 260 volts.
I drove the Subaru to the lake and I can't stop thinking about you. I want you back, fishing rod.
You think you can just leave me in the garage, then have me back in the spring?
I miss you.
Well, maybe you should have thought of that before leaving me for snowboard.
It was winter. I thought we were on a break.
It's called ice fishing, Eric. Look it up.
So cold. Reunite.
So there it is, it works. Oh, I wonder, I think I should make the extra effort just to reinstall that tube so that it looks original. Shall I or shall I not? Should I do that? What do you guys think? Good idea? Put the diodes in a couple of pieces of heat shrink tubing and just connect them and leave the tube socket wired to the transformer so that the tube will light up like it's original, but it'll work without having a short circuit. I think we'll do that. So to do that, I'll go in here and I'll remove my diodes again that I just put in to the diode. Like that. Solder it on.
do the other same thing for the other diode and wire the two other wires that go out from the tube. We'll take them off now. These are the DC wires. There's one, that's the one that goes to the output transformer, and this is the one that goes to the main filter. So here's our B plus wire. We'll just expose a little more of it. There we go. Okay, now what we need to do is we'll prepare a piece of heat shrink. It's going to have both the transformer wire and this wire pushed through it. Okay, I'll put my little piece of heat shrink on here, onto this one. And then we'll join it to the diode here. Okay, now what we need to do is we need to join these two together and then join it to that and bring the piece of heat shrink tubing up to cover the whole connection. That way it won't short out to anything inside the chassis. So we solder those two first, and then we'll solder it to these two. And then we can bring the heat shrink tubing back. Bring it right up to the diodes like that and shrink it. That'll prevent shorts. Okay, now this connection is safe and we can just zap tie it or something to one of these other wires just so that it doesn't touch anything. Okay, wires are safe. We can now put the old rectifier tube back in. Now remember, the filaments are still connected on this, so the rectifier tube will light up like it did before, and the radio will work. So now it looks original. The tube is going to light up. There's no tubes missing. And the radio will work.
To great success. You know, they've got key players and key areas, and I think they've got one or two injuries as well, which most teams have. But you know, every game is hard in this league, whether you're an expansion team or a storied franchise. I'm expecting a very, very difficult game. Coach, thanks for this. Good luck tomorrow. Thank you.
So there we go.
You gotta seize the data.
Stay connected with Virgin Mobile. Plans with 2 gigs of bonus.
Why two volume controls?
Prices. And Starbucks and more.
Weird, it's got two volume controls.
To be a member.
That is.
Paint, and get ready to tackle that painting project. Cloverdale Paint has everything you need, including...
That's really weird. Got 2 volume controls on it. Hey, that's it. It's fixed. It's fixed. It looks original. The tube lights up. You can't see it in the lights here. You can't see these ones either. They're pretty dim, but they're warm. So the tubes are lighting up. Now it looks original. Has all the original parts in it. I didn't even have to change any capacitors in this thing. It works. So that's it. Thanks for watching. We'll catch you again. I have another old. What is it? It's a Normandy. I have another old Normandy. I have the whole console. The turntable has been removed. I have to find a record player for it, but I have the whole console, and it's a shortwave AM radio that was my mother and father-in-law's, and I've now inherited it. So it will be going under a full restoration, and the cabinet on that one is in like mint condition because it has been covered up, and it's been sitting around for years. It's going to have a full restore done on it in the not too distant future, but I wanted to get this old chassis out of the way first. We'll catch you later.